Hi all. Today we are going to look at how do we determine kurtosis as well as skewness in case of data in Excel. Let's say I have sample data, salary data of 20 people, sample data per se. And if I wish to determine the statistical data, what I need to do is I need to first go to data over here and I need to have data analysis. If you're not having data analysis, let me tell you how to get this. So firstly, go to File, More, Options, go to Add-ins. Here, click on this Analysis Tool Pack. Select Excel Add-ins, click Go. It would be unchecked if you're not having Analysis Tool Pack. Just check this, click on OK. You will have the data analysis over, right? Now that we have the data analysis, we'll just click on this. Go to Descriptive Statistics, Input Range, A1 to A21 by columns. I have the labels. I want the output, let's say F1, I want the output to be in. And I want to see the summary statistics, confidence level, kth largest as well as kth smallest. So 1 is for the first one. If I click on OK, what I'm getting is this data, wherein I have data ranging from mean, error, median, mode, standard deviation, variance to kurtosis and skewness. The data that is relevant for discussion today for us is kurtosis as well as skewness. So firstly, what exactly is this term kurtosis? So kurtosis is a measure of tailness of a distribution. You are measuring tailness of a distribution per se. So what exactly is a tail? It's like checking out how often the outliers are occurring. So outliers is something which are extreme values, but these are plausible values. So for example, let's say we have a set of data wherein amongst all the participants, the height them is somewhere ranging from 5'5" to 6. Suddenly we have one of the values which is 7. So 7 would be an outlier. It's an extreme value, but it's a plausible value. So kurtosis is measuring the tailness of the distribution, and tailness of the distribution comprises of the outliers per se, right? So what this is telling us is that as a tail per se, it's the frequency of values which are extremely high or low as compared to the mean of the data. Now here we have got a kurtosis value which is minus 1.5. So if the value of kurtosis is less than 3, which we have over here. So this is a thin-tailed distribution. Okay. Now, thin-tailed distribution is also referred to as flatted Kurtic distribution. Okay. So further, if we have to look at skewness then, so skewness is coming out to be 0.003. It's a measure of distortion. When we say measure of distortion, we are looking at, or rather checking out what is the asymmetry in case of a distribution. So it could be a positive value, it could be a negative value. So positive skewness refers to more fatter tails on the right. Negative skewness refers to fatter tails on the left side. Here we have a positive value, so we have got positive skew. Now, skewness as a concept is very helpful when we are looking at data, let's say financial data. So suppose over there, if we have got positive skewness, that means the outliers are lying on the right, on the positive side, that's the profitable side. So we will have more data on the left side, but the value will be lesser, right? So our losses will be less and our profits would be higher whenever they would be. So this is how we can analyze or utilize data of skewness, let's say when we are looking at financial data or investment data. So this is how we can determine kurtosis and skewness and look at the data and analyze our distribution per se. So I hope this was helpful to give an idea of what exactly is kurtosis, what is skewness per se. So if you have liked the video or if you have found the video helpful, please press the like option. And if you want to, more such videos, want to see more such videos, please subscribe to my channel. Thank you guys for your time.